Welcome to LIB Academy. Let's look at one of the tricks to solve gamma problems. Gamma functions is one of the ways that we use to solve difficult integral questions. Difficult integral problems. Let's say if I am to integrate from 0 to infinity of x to the power 2 e to the power minus x dx, and from 0 to infinity x to the power 250 e to the power minus x dx. It would be easy for me to integrate this as compared to this. But with gamma functions, you can easily integrate any of these with a little bit ease. And the general definition for a gamma function is the symbol is gamma of n plus 1 equal integral from 0 to infinity x to the power n e to the power minus x dx. So this is the general definition of a gamma function. So if you see any integral problem where the limits are from 0 to infinity, you can use gamma functions, the idea of gamma functions, to solve them generally. So now let's continue with the trick. If I have gamma from 0 to infinity, we know that for gamma functions, the limit of the integral is from 0 to infinity x to the power n and e to the power minus bx. The shortcut formula to solve this is n factorial all over b to the power n plus 1. So this is a shortcut formula that we are going to be using. For example, number one, evaluate integral from 0 to infinity of x to the power 6 e to the power minus 3x dx. First of all, if we compare this to the general gamma function formula, our n here is equal to 6. The term of the variable, whether either x or y, gives us its power is n. So in our b here is 3, not negative 3, but 3. So b equal 3. We also have to look for the value of n plus 1. So n plus 1, n is 6, plus 1 will give us 7. So now we just go ahead and evaluate it. So it's n factorial all over b to the power n plus 1. And our n is 6. So this will give me 6 factorial all over b, which is 3, to the power n plus 1. This was n plus 1, which is 7. So 7. So now punch this on your calculator. You are going to get 80 over 243. That is the answer for this problem. Evaluate integral from 0 to infinity x to the power 4 e to the power negative x dx. Now, looking at this, you can see that the limit is from 0 to infinity. So you can use the idea of gamma functions to solve this. So our n here, you know our n to be 4. And our n plus 1 is going to be 4 plus 1, which is 5. And our b is 1, not negative 1, but 1. Our b equal 1. And then, and the formula that we are using is n factorial over b to the power n plus 1. So our n is 4. So 4 factorial all on b to the power 5. And our b is 1 to the power 5. So 4 factorial equal 4 by 3 by 2 by 1 all on 1, which equal 24. Or better so, you can use your calculator. 4 factorial, you have 4, then shift plus this sign right here to give you the factorial sign, then over 1, and you are going to get 24. So that is it. For any gamma problem that is of this form, you can use this general shortcut formula to solve it with ease. But an exception to this trick is that if I have to show it to you so that you find yourself wandering somewhere or trying to use this idea to solve certain problems. If the exponent of x, which is our n, is a fraction, or if the exponent, the variable x here has a power more than 1, either this one has a fraction term or this one has a power more than 1, then it ceases to use this formula. So you can solve problems of this form, 0 to infinity x to the power 2 over 3 e to the power negative x dx. You can solve problems of this form using the shortcut that we just talked about. It's kind of going to be tedious. Rather, you can use the normal gamma function idea to solve it with ease. So you can check my video on that or find a way of handling those problems too. So once the power, one of the power ceases, if this one has a fraction term, you cannot use it. Since this one has a fraction power, which is our n, you cannot use it. But even though this one has the variable here, has not, its power is not more than 1, but you cannot use the general shortcut formula. So that is what you should take note of. So that is it for this video. You can check my playlist on gamma and beta functions, where we dealt with a lot of problems. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.